So the question we're going to do today is top k frequent elements, question number 5 of our playlist, NeetCode playlist, and it is a 347 question on LeetCode. So what is the name? Top k and frequent elements. That means we will have an array, let's say 1, 1, 1, 1, 2, 3, and 4, 4, and 5. This is the array 3, 1, 2, 4, 1, 5, 3, 1, 1, 3, 4. So we want to take the frequency of each element, and then we have 5 elements. Let's say the k is 3. So we only need 3 elements based on the frequency. The highest frequent 3 elements we want as the output. So how to do this? First we will make obviously a frequency map. So let's make the map. The keys will be the elements and the value will be the frequency. So we have 1, 2, 3, 4 and 5. So in one loop we can just make the frequency map as we have done in previous questions also. So when we go to 3, we mark it as one frequency. It has occurred once. Then 1, 2, 4, 1 again, so it becomes 2, 5, then 3, so it increases to 2, 1, 1, 2 times, so 4, 3, and then 4. So we can see that 1 is 4 times, 2 is 1 time, 3 is 3 times, 4 is 2 times, and 5 is 1 time. Now we need 3 elements out of these which are the highest frequent. So that will be 4, 3 and 2. 1, 3 and 4. Okay, so the answer will be 1, 3 and 4. So this was the brute force solution actually. The making the map is constant. In each method we have to make the map because we need the frequency of the element, and the array does not give us the data. The array just gives us the indexes and the values. So we made the map. Okay, so now how do we get 3 elements? The map has 5 elements, we need 3 only. So we will do one traversal for this and we will get the max frequency, which is 1. So we got 1. Then we remove 1. 1 is removed. Now out of these 4 elements in the map, we do another traversal and we get 3, the next max. And then we remove this also. Then we have 2, 4 and 5. Then we do another loop and then we find that highest frequent element is 4. So we got 4 and this is done. So what we did was we looped the map k times to get k frequency, k most frequent elements. So the time complexity will be O of n into k, because each traversal is O of n and we do it O of k times, because if the size of map is n, so the one traversal is O of n and we do it 1, 2, 3 times, which is k. So O of n into O of k, that is O of n into k, and the space will be O of n, because in the worst case, if each element is unique, then we have n size array, then we have n keys in the map. So that is the O(n) size space complexity. We got O(n) into k time and O(n) into space. So now we need to further optimize this somehow. Space will be stay the same because we need a map in all the methods, but we can do something in time because n into k is like doesn't look very optimal. So we will try to do it in a better way. As usual, if we need to find something better or solution, so we try to do sorting somehow. So the map will stay constant. We will only change the logic after the map. So let's just erase these things. So we have the map. Okay, we made the array into a map. We have the frequency of each character. Now how to get, this is the main part, how to get k highest in the best way possible. So what we're going to do is we will convert this into an array, a 2D array, which will be the key, the element, and then the frequency. So 1 came 4 times, this is a pair. 2 came 1 times, this is a pair. 3 came 3 times, this is a pair. And 4 came 2 times, this is a pair. And 5 came 1 times. So this is our array. Let's call it ARR. This is our array. Now we have the frequency and the key of each element. Now we need to take the k best out of these. So this and this and this. But how do we know that after this is the max, this is second max, this is third max? This can be in any order. So what we're going to do with is we are again trying to make it into a fixed order so that all these 3 values are like neighbors of each other. So what we're going to do is we will just sort this array based on the second element. Using custom comparators in any language, we can do this to sort this array using the first index element of each pair. So after sorting, it will become we will do it decreasing order sort. So we will get 1, 4, then 3, 3, then 4, 2. Then these 2 elements have the same frequency, but as this is shorter, so it will come later, 2, 1. We can also set this in the custom comparator rules. So now we have this array. So simply just take the first 3 elements, first k elements, which is 3 here. So we got it. So what we did was here, earlier we had O of n into k because we did O and loop k times. But in this question, we don't do that. We just sort the array. So the space stays same O of n because the map is O of n, but so the map is O of n, then the array is also O of n, and in sorting it we take n of log n time. So the last one was n into k, now we got n log n. So log n is better than k because but if n is equal to 10 and k can be 9 also, but log of 10 will be like very small. I think it will be 1, I guess. It will be very, very small, so it wouldn't matter much because k is pretty large. Now we still have something in the multiplication, n into log n. So if n is very large, then log n will be also larger. So now we need another method to solve it, which is better than this one. So we saw here that we just want k elements, but we are sorting the full array. Let's say if total array size is n is equal to 100, there are 100 pairs, but we need only k is equal to 5. Then why are we doing n log n? Because n is very large, but we need 5 elements. So we need to find a way so that we just take what we want and don't bother the rest. Let me erase this so I can explain you better. The array will stay same, but in this method we will use a heap. So let's just consider this as a heap. We took each key and the frequency and added it to a heap, and this is our heap. Okay. Now this is the min heap. You might wonder why we don't take max heap instead, because we need top k and not bottom k, like least k frequent elements. I will explain that later. So this is a min heap. Same as array, is just that whenever we pop an element from min heap, we get the minimum element. Okay. No, actually, let me just erase this because we are going to do it step by step. Let me erase this also. Okay. So this is our map. Map is fixed. Map we have to make in every solution. Now what we are going to do is we made a min heap. So we add an element 1, 4. This pair is added. And then we add 2, 1. Then we add 3, 3. Now there is one condition on the min heap, that the size is 3 now. So why should we add one more element? Because we are assuming that min heap will also always have all the answers. So now we assume that this is the answer. Top three frequent elements are these. But this is not actually the answer, but we considered it. We put a condition that the heap size should always be 1. So when we go to the next element, which is 4, 2, we added it. So now the heap size is greater than k. It is 4, but we only need 3 elements. So that means one of them is definitely not the answer. Okay. So what we are going to do is, that's why we took min heap and not max heap, because we cannot remove this because this is higher number. So out of these 4 options, which one of them is the least likely to be our top k frequent? So we compared them with each other. 4, 3, 2, 1. That means this element will definitely not be the answer, because these 3 are greater than this. If we have to take top 3, like if there are 5 guys and these are the top 3, so if we can find one element that is greater than, no, actually wait. Okay, so we know that this element is less than 3 elements at least. So if an element will be in the top 3, then that means this is less than 0 element, this is less than 1 element, and this is less than 2 elements, because this is top, so it is a rank 1. It is the biggest. It is the biggest, just smaller than this one. It is the biggest, just smaller than these 2. So that means if an element is less than 3 elements, that means it is definitely not in the top 3. It is the best case, the 4th rank. So in this case, we can see out of these 4 elements, this one is less than this, and this. That means this is out of the question. This is definitely not the answer. And also our min heap property says that the smallest element will be popped out. So whenever size is greater than k, we pop the smallest element. So now we have these 3 in the heap, which can be the answer or cannot be. We will see later. So now this is done. Now we go to this. Now we add 5, 1 to the heap. Now again, similar case. Size should be k, but size is k plus 1. 1, 2, 3, and 4. So that means one of them is not the answer. 4, 3, 2, 1. Shortest one is this. So pop it, because this cannot be the answer. So the whole map loop is done, and we have 3 elements in the heap, and k is equal to 3. So these are the answer. So we just written this. So what did we do in this question? We did total 5 inserts. That means n inserts, and each insert took log of k time, because in the heap there is a formula that says that to insert an element to a heap, max heap, min heap, doesn't matter, the time it takes is the log of size of heap, log of size. And in this question we specified that the size can never be greater than k, so we take size equal to k. So one insert take log k, and we did n inserts, so time complexity is n into log k. Previously it was n into log n. So we did very little bit optimization. The log n converts to log k. K is in the worst case equal to n, so then it will be n log n also. Both will be equal. But in average cases, k can be smaller. What if n is 10 to the power 5 and k is just 10? So this is way smaller than this. So the log of this will also be way smaller than this. So this method is slightly better than the previous solution. So this method still took n into log k. What if we are more greedy and we need a better solution? What if we can just remove this and get it to on? So let's try it. Let me erase this part. We'll just keep the array and the map because the map stays same, and we will erase everything else. Okay, so we have the array map now. So what if we create an array of every possible frequency? In the worst case, an element can be occur 0 times, and in the max possibility of an array of an element occurring is the size of the array. Because let's say if every element is 1, that means 1 occurred n times because n is the size of the array. Any element cannot be greater than n times because the array size is n. So we make an array, we call it bucket, and we use its size as n size. Okay. So for all the n, each element will be an array. So all the zero frequency elements will go there, all the 1 frequency will go there, 2 frequency, 3 frequency, and so on, and n frequency is here. So let's take it n plus 1. So what we're going to do is we traverse. Let's for a second forget this case and just change the values. What if it is 3 and wait 1? Okay, let's keep it like this. So we saw 1, so we added it here. Sorry, we saw 4, so we added it in the fourth index. In the fourth index, we added it here 1. The array is actually bigger, but there is no element that has occurred that many times. So that means fourth frequency is 1 element occurred 4 times. Then in the first index we had 2, then 3 goes here, and then 4 is the element that has occurred 2 times. So that means 4, and then 5 here. So now we saw that 0 frequency we don't have elements. For 1 frequency we have 2 elements. For 2 frequency we have 1 element. For 3 frequency we have 1 element. For 4 frequency we have 1 element, and array goes on. So we still haven't used any log because the heap uses extra log for inserts and pops, but we just use a map to an array. We just converted a map to array, so it is still on. Okay. So now what we're going to do is we need top k. So that means this is the lowest, this is the highest. So we start traversal from here, and we keep taking elements 1, 2, and 3. So now k is done. That means 1, 3, and 4. 1, 3, and 4 were our top k frequent elements. So we were able to do it in O of n. First we converted array to a map, which is O of n. Then we converted map to our bucket array, which is also O of n. And then we did one loop on the bucket array to get top k frequent elements. In the worst case, we have to do the full loop. So again, O of n, which is equal to O of 3n, which is equal to O of n only. And the space is O of n because we made map and array. So this is the best solution. We were able to do it in linear time. So that's it for today. Thanks for watching, and I will see you in the next one.